I rode a motorcycle to the top of Queensland 2 years ago. Yeah, no, it's that state there. All the way to the top there. There's a lot of crocodiles up there. And there was a place that we camped, this is just me and a friend, called Saltwater Crocodile Creek. Well, it is. And what you've got to do is not go near the water. And you've also got to give so when, you know, like the parent crocodiles need to get from the water up to their eggs in the bush, and you've got to not camp in between there. And then you're right. Yeah. Oh, they're in the bush somewhere. As long as there's a path for them to get there. Yeah. All right. Did you guys come from the talk downstairs? Yeah. Is that finished? All right. Shall we get going? All right. Let's get going. All right. Well, hello. My name is Tony. Thanks for having me here in Boulder. This is my second time coming back here, and it's brilliant again, this conference, in my opinion. Maybe yours as well, hopefully yours. Bit of an introduction. I live in this place. It's called Brisbane, Australia. This is the Brisbane River, and that bridge is called the Story Bridge. So that's what we call the city of Brisbane. It is located here, right on the coast of Queensland. That's the state of Queensland. That's the coast. That's how I like looking at the coast. That's a place called North Stradbroke Island, just off the coast of Queensland. And I work at this place. And what this place is so CSIRO is the Commonwealth Scientific Research Organisation of Australia. It's a federally funded research organisation. And in collaboration with the Queensland State Government, I run the Queensland Functional Programming Lab of 6 people. And our job is to make functional programming accessible to everybody. Isn't that a cool job? Some people say. Yeah, it is a cool job. And another question I often get is, how do you convince your government to fund you to write Haskell? And I don't know the answer to that question. It just happened. Well, the real story is that our state government wanted to invest some money in innovation, and they were convinced that functional programming is the way to do that, without knowing what it means. And here we are. So we have a meetup group in Brisbane called the Brisbane Functional Programming Group, and I've talked about list folds before, and I'm going to do the same again today. So basically, I'm going to do the same thing. I'm assuming everyone in here has heard of fold right and fold left, and that's about it. All right, does that sound fair? Is that reasonable for most people? And it's a beginner thing. I want to make it, I want to target beginners who don't know how to use these 2 functions, fold left and fold right, and give you an intuition to know how to use them. All right? And I'm going to be very explicit about that intuition. Like I want to install some software in your brain. All right? That's what we're going to do. So let's remind ourselves, what exactly is a list? Who knows what a list is? What's a list?
It's a collection of the same type of objects with pointers to the next object.
Yeah. That's one way of putting it. Yep. So I'm going to give you this definition, which meets that definition, which is a list is constructed with nil, and nil has no associated data, or cons. And the reason I use the word cons is because it's been around for decades, so I'm not going to use a new name. And the cons construction is associated with a value and another list. So all lists are one of these 2 things, and never anything else. So we can write that in Haskell notation, and we say here that nil is of the type list of something. It takes no information and just gives me an empty list. And cons is given an element and another list, return a list. Okay? So, canonically, the element, the first element of that list is often called its head, and the other part is called its tail of the list. If you use other programming languages, you can actually write it using these languages. So we have an interface called list. There are two ways to construct it. One is with nil. There's nothing in the constructor, and the other one is with cons. There's the element, and then the rest of the list in the tail. And there are some tricks to make it so that you can't, because it's got to be exactly two things. All right. So in C#, an interface is a open world. So there's some tricks where you can close that world off. Here's the actual Haskell notation, and this says the data type called list is parameterized over A. That's the element type. It is constructed either with nil, with no arguments, or cons. Cons has a value of the type A, and then another list of A. Okay. We can construct lists. So in C#, this is the list that just contains the number 12. We would call cons, we'd give it the element, the head of the list. We have to give it another list again, and in that case we give it the empty list. Same in Haskell, and when we print it, it looks like that. Okay? We could construct a list of the characters A, B, and C. So we would call cons, pass in the character A, then we'd have to pass in another list, where we'd call cons, pass in B, pass in another list, C, and then nil. Okay, so that's how we construct these lists. We call cons until we finish the list with nil, recursively. Just some, you might see some different words. You might see nil notated like that. You might see cons notated like that. And there it is. There's 1 cons, 2 cons, 3 cons, nil. So where the arguments are, the head is on the left of the cons, so 1 and then the rest of the list, and then 2 and then the rest of the list, and so on. But that's the same data structure, and that's called a cons list. Okay? So, does everyone know what a list is? It's either nil or it's cons. Okay. So, who's heard of right folds and left folds? And for whom is it true, and that's all you know? Okay. Well, what else do we know about fold left and fold right? What can someone tell me about fold left?
Can't use it on an infinite list.
You cannot use it on an infinite list, that's true. Anything else? What about fold right?
Is that true in Haskell and Scala, or is it both? Okay.
Yes, it's true in the universe.
True in the universe.
Yes. And we'll see why. Let's have a look at why. So, in Haskell, just some names if you come across these things. Fold R, fold L in Haskell. Scala, it's called fold right and fold left. C# doesn't have it, but it does have aggregate, which is like fold left. And I wrote fold right and fold left in C# a long time ago. So these are the kinds of questions I want to answer today. I get this question a lot. Someone in this room probably has this question. I hope you do. So when do I know which one to use? And what do they actually do? So there's if you type it on the internet and you have a look, and you'll see diagrams like this. They're accurate, those diagrams, but they're not helpful. They don't answer these questions. Not straight away, they don't. You have to take these diagrams and develop an intuition from these diagrams to know how to answer those questions. Sometimes I've seen this before, that's not true. That's also not true. But I'm just giving you examples of things that I see occasionally, and you just end up with. That's why I get the question all the time, because you get these not quite accurate answers to these questions, and I'm hoping to give you dead accurate answers today. That's for today.
I really like always use fold right, always use fold left, because fold right is inefficient.
Oh, okay. I have not heard that one for a long time. Yeah. It's one of the things that some people say is always use fold left because fold right is inefficient. That's layers of wrong, that one. Yeah. No, it's neither way around. Well, let's answer this question, and then we'll ask that question, and we'll find out. So they're different functions. And importantly, in the intuition I want to give you, they're going to be completely different intuitions. All right, so let's talk about fold left. All right, so fold left takes a function, b to a to b, and a b, and a list of a, and it folds left on that list using those two values, f and z, and it returns a b. So this is quite a like lots of detail in this definition, but we don't need to know about all that. How does it take those three values to return a value? Like this. So, does everyone remember for loops? I've not written one for a while, but I remember they look something like this. And I'm sure everyone's written a bit of code that looks something like this. And importantly, look at these three things. These are the arguments that came in to that for loop. So let's solve a problem using this for loop, all right? Such as sum the integers of a list. If you had to sum the integers of a list, and I said you could replace z and f with anything you like, what would you do? Z equals 0, and f equals plus. Okay? So if I substitute z with 0 and f with plus, the returned value will be the sum of the lists. And in fact, fold left does exactly this loop. If you open up the source code to it, you won't see a loop, but you can think of it as doing exactly this loop. What happens if that list is infinite? It never returns, as it was pointed out earlier. Fold left won't work on an infinite list because it does exactly this loop. So I've substituted z with 0 and f with plus, and now that adds up the integers in the list. There's the source code. There's two equivalent lines there. One's just point freestyle. So I can say that the sum is fold left plus on each iteration in the loop, starting at 0. That will add up the list. Okay? What about multiplying the list? Well, z will be 1 and f will be multiply. Just like that's an error. That should be 1, not 0. But yeah, if that were 1, that would multiply the list. It actually returns 0, right? Don't worry, I got tests. And there's the code. So product equals fold left. Do multiplication on each iteration of the loop and start at 0. So all left folds are loops. Who was in the workshop the other day, 2 days ago? So you remember having to reverse a list. We had to reverse a list. And this was towards the end of the day. And one of my goals was to get everyone to forget what loops are. And most people did. And we're having a hard time reversing a list, which was good. However, if you just remembered what left folds were, or loops, what if you need to reverse that list? I argue that if I set z to nil, the empty list, and f to the function that prepends a to r, that list comes back reversed. Does everyone agree with that? So basically, so r being the accumulating value as we spin through the loop, and a being the element coming off the list in the loop, I call cons, pass it a and then r, and I pass that in as the function. That will reverse the list. And therefore there's the code. Reverse is folding left with cons flipped starting at nil. And a funny story, which I told the other day, is I went for a job interview about 10 years ago. I think it was C#. I can't quite remember. But in the job interview I was asked to reverse a list. And I said, well, what language? And they said, any language you like. I said, okay, fold left, flip cons nil. And I didn't get the job. I mean, I was asked to explain it, and I was like, okay, well, you know cons list, right? No. Okay. So, anyway, true story. I think we're past that these days. I like to think we are anyway. So let's compute the length of the list, just to sort of emphasize left folds again. If I were to compute the length of the list using this loop, I would set z to 0, and f would be given r and then a, ignore a, return r plus 1. So plus 1 there being the function, they're given r and then a, return r plus 1. And both of these are solutions to that. So fold left, on each iteration, take the accumulating value r, then a, return r plus 1, start at 0. That computes the length of the list. Left folds are loops. Another way of putting this is, if I went up to all of your code and all of your loops, and I factored out all of the differences into a function, I would invent fold left. And then just pass in those arguments from the callers. Okay? So you may think of fold left as a loop. There are no inaccuracies in that intuition. That will always work. All right, even though when you look at the source code to fold left, you do not see a loop, but it is exactly equivalent. I just said that. So, yeah. I have known people actually who discover this by actually doing that refactoring. Apparently, different loops factor all the differences out, and then call the thing that you factored out, and that thing will be fold left. And I just want to emphasize the exactness of this intuition. Okay? So you will never go wrong if you believe that left folds are exactly that loop. So everyone remembers loops, right? Yeah?
I'm sorry, I still need help with duplication.
Mm-hmm.
Like, what's it? Where do we get duplicate?
Oh, okay. So imagine you and I are working together, right?
Yeah.
And I come across your code, and I see that, well, and that was 1, not 0. And I see another bit of code, and it was that.
Sure.
Right? And I say, hey, we've got some duplication going on here. Let's factor it out.
Yeah.
And then you reverse the list, and we did the same thing, and then eventually, that's what I'm trying to get at. So fold left is all your loops already all factored out. Yeah. As we know, it won't work on infinite lists. All the questions we can ask about fold left, we can ask about that loop. So that loop will never work on infinite lists. Therefore, fold left never will. And I can build this on your existing knowledge, which I just did. Right? Everyone knows what a for loop is. Well, except me, because I keep forgetting. But using that existing knowledge, I've told you what a left fold does. All right? Any questions? Everyone knows what a left fold does. It does exactly that loop. So var r equals z. On each iteration, call f, building up r, return r. Okay? Now the problem is fold right, I cannot use your existing programming knowledge. It's not a loop. It has a similar type. Function a to b comes in. Z is of type b. List is of type, well, that's the list that we're folding right on. And how does it take those 3 values to return the b value that comes back? Okay, so if left fold's a loop, what is fold right? Fold right does constructor replacement in a list. All right, so just picture any list in your head, any cons list. All right, it's got element, cons, and then a list. That list may be an element, cons, and so on. And wherever there's cons, the function will get substituted, f, and wherever there's nil, the z will get substituted. So if we suppose the list is cons a, so the head of that list is a, there's the tail. That tail is made up of more cons, and so on. If I call fold right, given that function f, z, all the cons is turned into f, and the nil turns into z. Okay? So fold right does constructor replacement. And the key thing is it doesn't do it in any particular order. It does it right associatively. So those parens are to the right. but that doesn't mean that it does the rightmost thing first. And I can show you examples of that, actually. So, how do you multiply the integers of a list? If this were all integers, A, B, and C, and D were all integers, and I wanted to multiply all of those integers, do you agree that I would substitute cons with multiply and nil with 1? Pardon me, that would multiply the list. I agree that if I turn that, turning cons into multiply and nil into 1, I will in fact get the product of that list. So similarly, product is the fold right, multiply 1. And this may be where that myth comes from about which is more efficient, because the fold left version in that particular case is more efficient. And that's because integers are machine integers. So, you got a list of booleans, and you want to say, make sure they're all true. Call AND on all of them. How about you got this list? You want to replace cons with AND, with Boolean conjunction. So that will go through the list, turn every cons into Boolean conjunction, nil into what is it? True? Can't remember. Yeah, true. I always get that mixed up. I have Boolean confusion. So go through the list, turn cons into conjunction and nil into true, and it'll perform conjunctions through the whole list. This idea of taking a binary closed operation like conjunction, so an operation that takes two of the same thing, two booleans in this case, and returning another boolean, and then another value that does nothing, in this case true, to that operation, is called a monoid. Just to give you a bit of Greek words. Have you ever come across this Greek word called monoid? It is the pair of these two functions, and true. This is an example of a monoid, where it's a closed binary operation. So it takes two things of the same type and returns a thing of that same type. It's associative. It can, if you did A and B and C and you put the parens on either side, you get the same answer. And true and anything is that thing. Right, that's the identity for the operation. That's a monoid. So monoids come out of lists quite regularly. We've actually seen quite a lot already. So I'm just being a bit explicit about that. How about we append two lists? So again, who was there the other day? Cool. So remember appending two lists? I'm going to set this as a puzzle then, for those who don't remember. So who were not there, right? So here are two lists, A, B, C, D, and E, F, G, H. And I wish to append list 1 and list 2. How might I achieve that goal? Using fold right. Be brave.
Wouldn't you just use one list of data?
Pardon?
Wouldn't you just use one of your lists as your starting initial value and then pull right over the second list?
I think you might be right. I'm not sure.
Plot list 2 into nil of the list plot.
Yeah, is that what you're saying? I think that is what you're saying. If I pick up list 2, if I just pick this up and put it right there, I win. Right? Do you agree? That will append the two lists. Or more discreetly, if in list 1 I replace cons with cons and nil with list 2, they'll get appended. In that list there, cons is going to stay cons and nil will be list 2. Just like that. And therefore, that is the source code to append. So append, given list 1, list 2, in list 1 replace cons with cons and nil with list 2. That will append two lists. Do you want to see some code? Let's write some code. Is that big enough?
No.
No? resources. How's that? Okay. So the type of fold right, and this says given a function. So the way you read. So who is unfamiliar with Haskell syntax? A few people. Okay, I'll read this out for you. This arrow here. Let's just ignore that for just a moment and read this and say it takes a function a to b. So that is to say it takes a function. That function takes a and a b and returns a b. Then it takes a b, and we'll read this out as, and then a list of a, and returns a b. And the type of cons is given a value, and then a list of values, return a new list of values. So therefore I can put cons into fold right. Alright, so basically because that a was that a, that b turned into list of a, therefore that b turned into list of a, because all the b's need to be the same. Gives me back a list of a, and again that says list of a, and returns a list of a. The list of a that we want to, so given list 1 and list 2, the thing that we want to replace nil with is list 2 in list 1. Alright, so that again is the source code to append. List 1. And this says given a list of A and a list of A, return a list of A. This appends the two lists. Let's try it. So if I take the list 1, cons 2, cons 3, nil, and the list 4, 5, 6, nil, and evaluate that, I actually have to do this, don't I? So apply that function to those two lists. It went through this list. It replaced cons with cons, and it replaced the nil with list 2, and that's why it came back as that. Okay? So fold right does construct a replacement. How about mapping a function on a list? Now we didn't get to that the other day, we didn't have time. I'm going to make an argument to you about mapping. Here is a list. Make it big. C, nil. Here is a list. Whoops, that's my fingers not working. And I want to map that function on that list. My argument is that I want this to occur. Do you agree? Alright, so if I want to map a function on every element in the list, I want to take that element and call f on it all the way through the list. In other words, I want to replace cons with cons and then f. Do cons and then f. And nil with nil. Okay? Because there's a little bit of infix operations going on here, but this cons turned into that cons then f. And as a general rule, this is completely off to the side, but as a general rule, when you say do this and then that, you often mean that dot this. All right. So has everyone seen those Haskell expressions? They look like this. And someone says, "What does that say?" Just another intuition. This is how I read it. Do G and then F. All right. So how about do plus 2 and then times 10. So I'll show you how that works, right? Let's go to the top. So plus 10 times 2 on 99. This is going to do times 2 and then plus 10 on 99. All right, so this is just another intuition. When you see that dot, read it right to left. Do this, then that one. So basically I'm saying replace cons with do cons and then f. So I have this list, A, B, C, D. I want to replace cons with, f and then cons is what I should have said. Tricked you. Yeah. Sorry, F and then cons. So given x being the element that we're visiting in the list, call F on it, and then call cons. And nil with nil. All right, so basically, yeah. So in the list, replace nil with nil and cons with F and then cons. This intuition works every time for fold right. Okay, so answers to the questions like when should I use fold right? It's a question I get a lot, and I don't know what else to say other than when you need to do constructor replacement. Or when do I use fold left? It's when you need to do a loop. Yep.
Can you do map with fold left?
Can you do map with fold left?
Is your accumulator just a loop?
Let's try. Alright, so we're going to say, map takes a function and then a list. Yep, does everyone agree with that? We're going to go fold left, we're going to do something. We'll start at nil. That's not nil, that's nil. On the list. And this is the accumulating value, and this is the element coming off the list. And I can put that element, I can call the function on the element, and put that on the front of the list. Okay? That type checks, let's assign it something. My map. The type of my map is that. So given a function T2 to A, a list of T2 return a list of A. That's map. Let's try it. My map plus 10 on the list 1, 2, 3. That's not map. Let's reverse it. Well, that looks like map, but is it map? Is it map? Who thinks it's map? I've set a trap. I'm being very, very mean right now. Okay. All right. I'm going to ask this. I'm going to call map the real map. Yep.
I have a question.
Sure.
If I did a for loop,
Hmm?
I would have been able to do a map, right? Because I would have been able to apply that function every element of the list.
Well, that's what we've done here for sure. Yeah. Except that also the list came back reversed as it went through the loop. So then I've reversed it back again. So I've applied the function through the loop. I've got the list back in reverse. Then I've called reverse. And so now that's why it comes out as this, right? So it goes through this list 1, 2, 3 and applies plus 10 and puts it on the front of a new list. So then it comes back backwards. And then I reversed it and now it's back around the right way again. But there's a trap. And the trap is this. I'm going to call the real map for a minute. I'm going to say call plus 1 on the list that goes 9 to infinity. All right? And this is going to be the list that goes from 10 to infinity. Do you agree? There's a built-in function called take. Take takes the first n elements from the front of a list. So I'm going to say map plus 1 on the list from 9 to infinity, and then take the first 3 elements of that list. And what should that do? Well, because it's Haskell, it gives me 10, 11, 12. What does it do in Java? Stack Overflow, right? Fails. Correct. I've got a sticker for that answer. Okay. What's that going to do?
Reverse is never gonna.
Well, fold left is never gonna.
Fail.
Correct. It's getting warm in here. So to answer the question, no, you can't. You almost can, but no. So we must use fold right to do map. And actually, I just got reminded of something. You can write reverse using fold left. But you can also write reverse to work on an infinite list, such that if you call reverse and then reverse again, and then do take 10, you should get the first 10 elements. This can be done, and it is the ultimate challenge that I set for people. I have stickers in my bag. So come and grab me and show me the answer, I'll give you a sticker.
Reverse and then reverse.
Yeah, so basically I'm going to walk up to your code and I'm going to go reverse, and then take 10 on infinity, and I shall get the first 10. It can be done. So you don't have to use fold left to right reverse. Okay, how about flattening a list of lists? We did this the other day. We have a list of lists, right, where each element is itself a list. We want to flatten it down. So here's my list, and there's a list inside each element. Do you agree that if I replace cons with append and nil with nil, they'll flatten down? Cons with append, or I've spelled append like that. But so fold R, append nil. Replace nil with nil and cons with append, and that list of lists will get flattened down. Okay? Has anyone ever worked on a team of programmers and someone says, I can't read this code? It's happened to me before. Yeah, it's happened. It happens. And I find this very readable. Replace cons with append and nil with nil. So I'm hoping I give you the ability to argue quite the opposite. This is quite readable. Because fold right does constructor replacement. Replace those two constructors with append and nil. Done. Alright, filter. We've got a list of elements. What do we replace cons with? Well, we're going to look at the element, and then we're going to say, does it satisfy the predicate? And if it does, put it on, continue, and if it doesn't, just drop the element. Another way of saying that is, given the element, there's the element as it goes through each cons cell. If it satisfies the predicate, then put it, so return the function that puts that on the front of the remainder of the list. Otherwise, the function that just ignores that element, and that is the function from list to list. Like given the rest of the list, just the rest of the list, ID. And nil with nil. There it is written in various ways. So basically, go through this list, turn nil into nil, and then on each head, so on each one of these, call it X. If it satisfies, then return the function that puts that on the front of the rest. Otherwise, just continue on with the rest of the list. And that will filter a list. Now, the thing about someone saying, I find that code really unreadable, this one came out recently for me. And I really want to try and make the argument this is exceptionally readable. So let's talk about what we're going to do here, right? So I'm going to write a function that takes an A and a list of A and returns an A. And its job is to get the first element from the list. But there may not be a first element. Like, what if it's nil? Right? In which case, return that A. Does that make sense? So if I pass in like 77 and then nil, I should get back 77. Because there's no head. There's no first element. But if I pass in 77, then the list from 1 to infinity, I should get 1. Because that's the first element of that list. Here's a list. What do I replace cons with and what do I replace nil with? I argue that the function that looks at the head, so in each cons cell there's a head and a tail. Given the head, ignore the tail, return the head. And set nil to the default argument that came in. So the default here being this value here. So replace nil with that value. And replace cons with the function that looks at the head, ignores the tail, and returns the head. Alright, so there's that function. X being the head and underscore being the rest of the list. And I argue that this entire expression here returns exactly that function. So constant A just ignores everything else and returns A, the head of the list. Unless the list was nil, If the list were nil, it would return the default, because all it did is replace nil with the default. Therefore, the function, the source code is head or is fold right, constant, the end. Or another way actually of saying it is, head or the default, replace cons with the constant function and nil with the default. That will return me the function that goes A to list of A to A. Get the head or return the default. Alright, because fold right does constructor replacement. Alright, this one is a little bit hard to talk about, just due to the nature of words against code. So basically I have a list of effectful values, f of A. Alright, so each element in this list, like A, B, C, and D, is an f of A, where f is something. Could be like another list, could be option, could be IO. And I want to turn it into an f list of A. Alright? This comes up all the time. Let me just show you something actually. Do I have the internet? Who's written this code before? Who has? Don't be liars. Everyone's written this code. Pardon? Sure. So given a list, set the list to empty, go through the list. If any element is null, return null. Otherwise, collect them all up and return it. Given a list of maybe null values, return a maybe null of list of values. That's what that does. Who's written that code before? Everybody has. Given an empty list, go through the list. For each element, call a function on a constant value x, collect the results. All of those are of that form. There are more. So a list of maybe null values, return a maybe null list of values. A list of given a constant argument, return a constant argument to list of values. How do we write this function using fold right? For each effect, whether it's IO or maybe null or argument passing, we want to replace each cons with, alright, so don't forget what the head is. The head is an f of A, and then the tail. I want to sequence that. I want to call, I want to call do on it, or bind, I should say. So I want to bind that, call the inner value x, then bind the rest of the list, call that y. So now I've got a value and a list, cons them, and call return. It all works out. So basically that's what I want to replace cons with, and nil I want to turn it into an f of list, where that list is nil, and all pure does is put the f around it. So that is the source code to sequence. So go through the list, everywhere you see cons, replace nil with return nil, and cons with lift two cons. Sorry? I'll write the code if you like. There's my code, there's my code. Fold right. So here's the type of cons. Oh, that's my little one. Where's my big one? There it is. The type of cons again is that. I might have to import that. Oops. The type of, it's called lift A2 cons. What lift A2 is going to do is put f around each of the values in the type. So cons was A to list A to list A. Lift 2 cons turned it into FA to F list A to F list A. And if I have a list of, let's go with maybe null values, or sorry, just maybe values, such as this. Right? And I want to sequence this effect. Actually, I write it out using cons, so it's a bit more explicit. Okay, there's my list. In that list, replace every nil with return nil. So turn it into an F of list. And everywhere you see cons, look at the maybe int on the left and the list of maybe ints on the right. And
Maybe listed on the right?
yes, it will, because the recursion's already happened in this function here. Yes. And substitute it with lift A2 cons. So just put Fs around all of it. And that came back as a not null, or a just, list of values. If any of them are null, let's remind ourselves what we're actually doing. Where was it? If any of them are null, return null, okay? Let's put one in there. Well, then the whole thing is nothing. And the other example was a list of functions. I'll need that still. A list of functions such as plus 10 or plus 1, let's go with that, times 9. I start getting a bit unimaginative with functions, let's go with that. Alright, so this is now a list of functions, and it returns back a function from number to list of numbers. So I need to give it a number, and it did the same thing. It went through that list, it replaced cons with lift A2 cons, nil with return nil, and that returned back an F of list, and I used F to be the function, so then I passed in an argument to it.
That's like map backwards.
What is map backwards?
Sorry, instead of applying a function to every the same function for every value, you're applying.
Oh, yeah, that's true. Yeah, it's true. Yeah, it's map. It's the map function where it's calling map, where the function is apply a function. Yeah. But they're all the same code. You know, like just fold right, lift A2 cons, return nil. So fold right may work on an infinite list. There was no order specified. All right. I did say that it replaces constructors, but I didn't say which constructor it gets replaced first, because there is no answer to that. All right. So you'll be walking down the street next week, and someone will say fold right folds from the right, and you'll say this: fold right cons. So replace cons with cons and nil with nil in the list 1 to infinity, and let's just take the first 4, and then you'll say to them, where is the right of that list? There is no right of that list. That list goes to infinity. And so no, it didn't. Right? It did not start from the right. It associates to the right, but it didn't start from the right. That's a critical difference.
So in non-lazy programming languages, it would have to start from the right.
Well, I mean, I know Scala does have a potentially infinite stream, in which case that still works. So when we say so the list in Scala, which cannot be infinite, and if I open up the source code, yes, it does start from the right. Or it does twofold lefts actually.
All you have to do, even in a strict language, all you have to do is use a different type for your cons than you might expect. So
Yeah.
instead of A to B to B, use A to thunk to B to B.
Yeah.
And then it doesn't matter what the semantics of your language are.
Because if I do the constructor substitution in my head,
Mm.
I end up with a bunch of functions to execute, and I try to run it in my head,
Mm.
I have to run it from right to left. Right? Or not?
Well,
No?
let's try it. So in this list, replace cons with cons and nil with nil, if you ever see nil, and then take 4. And I don't need to count to infinity to do that.
What if,
Do you agree?
I agree. But what if it's like a division of
Division. Division in here, when I'm replacing cons, you mean? Like here?
yeah, you do a folderized, where you divide the final elements by the element before that, by the elements before that.
Well, because we're using strict integers, then it won't terminate. But if we use, say, if we use like natural numbers, although you can't do division on natural numbers, but if I use like a lazy number type, then I would get the same, it would turn out the same way. So it associates to the right. It doesn't necessarily start from the right.
So the trick you use to get the head is in both right and const.
Yep.
It would still be constant time.
Oh yes. Yeah,
It doesn't
for
have
sure.
to, like, go through the whole list to get the head.
No. Yeah, I mean, that didn't count to infinity. For sure. So I just said, go through the list everywhere you see cons, replace it with const, you know, the function that takes the head, the tail, and returns the head. And it just applied that. In order to print out the answer, it didn't need to count to infinity. And the nil constructor may not ever exist. It certainly doesn't exist in that list. There is no nil. It's just conses all the way. And if we call fold right cons nil, that leaves the list unchanged. We can easily calculate. That's trivially observable. And it produces an identity function. So given in the list, it will return the same list. Left fold performs a loop. Who thought loops would be useful? Turns out they are. For getting intuitions about left folds. And right fold does a constructor replacement. And as we know, left folds will never work on infinite lists, and right fold might. And this works. This is true for all programming languages. The thing I like about these two intuitions is they are precise. That's what I like about them. I don't have to put any little footnotes. I don't have to say, oh, except for this case over here. There's no footnotes. They're the best kinds of intuitions, I think, anyway. So, I hope you can go away and solve problems using folds now. The end.